Hello class, welcome to the third video for our summer session, and in this video we're going to be talking about categorical syllogisms. Now, categorical syllogism is taking the tools that we've learned from the last two sections about deduction and validity, in addition to our Venn diagrams, and applying these tools to arguments. So what we'll notice going forward through this lecture is that there's a difference between the truth of an argument and its validity, and likewise how to formalize these very particular kinds of arguments, the categorical syllogisms, what they're composed in, and how to represent them again in Venn diagrams. And we'll be able to tell whether or not our arguments are valid based on how they end up being parsed out in our Venn diagrams. Okay, so what is a categorical syllogism? As we learned last week, categorical logic was originated and written down first by Aristotle. And Aristotle spends a lot of time talking about a whole bunch of different syllogistic forms of argument. All of these forms have three sentences. And the three sentences can be translated in what's called or known as standard form. So the standard form of a categorical syllogism will have three very important elements. We have first our major term, we have second a middle term, and third a minor term. So our major term is just the predicate of our conclusion, and all of the conclusions that I've written up here are marked 3. We have our minor terms, which is the subject of the conclusion, and then finally we have a middle term. And the middle term will appear in both of the premises of our arguments, but it won't appear in the conclusion. And it's the middle term that operates as the inferential power that connects the major term and the minor terms together to give us hopefully valid conclusions. And if it doesn't fit this standard form quite right, we'll find that the arguments are going to be invalid. And so really there's a couple ways of looking for validity. Now, what I've done is I've written up 4 different arguments on the board. So the arguments are separated by the squiggly lines. I apologize for clumping them all together. And then these straight lines, again, as I've indicated, I think it was in the first video, but it might have been the second as well, are just therefore. So the straight lines indicate conclusions. And then I've prepared us to mark down the inferences present in each of our premises and conclusions so that we can map out the validity of these arguments. Okay, so your most basic categorical syllogism, the one that I'm sure you've probably heard before, but if not, this is now your time to know it for the rest of your life, which is that all men are mortal, Socrates is a man, therefore Socrates is mortal, right? And this is sort of our cut and dry standard cliche argument, categorical syllogism, that's valid. And what we'll notice is that all men are mortal is an all S is P kind of statement. Socrates is a man is an existential statement. Some Q is P, and then we get therefore Q is S, or whatever. And so we're good. That example is just sort of, it would be a mistake on my part if I didn't share it with you, but we're going to look at some other examples here that I've written down that will help show us how to work this all out. So, so let's begin. Okay, so our first argument is here, 1, 2, 3, and our first premise says that all ducks are green. Our second premise says that nothing that's green swims, and straight line indicates conclusion. 3, and again these 3 dots just mean therefore. 3, therefore, our conclusion, no ducks swim. So this is going to be our first categorical syllogism. We'll find out if it's valid, and we'll learn a little bit something about the difference between truth and validity in working it out. So let's do it in our top left set of Venn circles here. And you should notice that I've labeled all of these circles differently. So in this top left set of circles, I have S, M, and P. In the bottom left, I have P, Q, and R. In the top right, A, C, and B. And in the bottom right, X prime, X prime prime, and X prime prime prime. And what the reason that I did this is because the way in which you translate the sentences or the terms, right, our major, middle, and minor terms of our categorical syllogisms into a form that's going to be Venn diagrammable requires the use of a variable. But it's not important that the variable be any sort of particular letter or number or symbol, just so long as it's consistent, just so long as the variable that you pick always attaches itself to the same term. So this is just to show that we can attach any variable to any term just so long as we're being consistent. So again, starting in the upper left, we have S, P, and M, and the first thing that we have to do is determine what our terms are. So if we're looking up here, we should notice that all ducks, so ducks is going to be one of our terms, are green. Okay, and nothing that's green also swims. We've already marked green as one of our terms, and swims as well. And now we have everything that we need, right? We have ducks, green, and swims. So we can circle those in the conclusion as well, and we know what our terms are. Now our major term is going to be the predicate of the conclusion. So our major term is swims, right? And our minor term is the subject of the conclusion, which is ducks. And our middle term, again, is going to be the one that doesn't appear in the conclusion, which is green. Okay, so let's say that M equals ducks. Let's say that S equals green, and P equals swims. Okay, so now we have a way to test the validity of our argument using the Venn diagram with all of our terms picked out. And the way that we're going to treat this with the 3 circles is just the same way that we treated it with 2 circles. And the way that I like to think about it is anytime that I'm dealing with any of these sentences and putting them in the Venn diagram, I'm just treating it as if it were a 2-circle Venn diagram. Because the 3rd circle can get kind of confusing, like where am I supposed to draw my shading or my X's or whatever. And so when I do these, I subtract away. So for instance, this first sentence has to do with ducks and green. And over here, the intersection of the circles ducks and green is right here and here. So I'm just going to imagine like this P circle, the swim circle, isn't even there when I'm filling in my shading and whatnot. So let's do that. It says all ducks are green, and if we know that all ducks are green, then we know that if something's a duck, then it must be green. And this means that nothing can live in here, right? This is what we learned last week. And now notice that I've shaded in this area, which has an intersection of ducks and swimming. And that's because I've ignored the swimming circle, which is important, because what the logical content of our first statement tells us is just that if something's a duck, then it must swim. So there's no such thing, or that must be green. So there's no such thing as a duck that isn't green, and anything that would live in this little part of the Venn diagram would be a duck that isn't green, and that's logically impossible given what we've learned from our first sentence. Okay, so let's do our second sentence now. Nothing that's green swims. So now we're dealing with green and swimming, so I'm going to ignore the top circle. And what we learn here is that if something is green, then it doesn't swim. So nothing that's green swims. I'm looking at the intersection of these 2 circles, so I'm going to shade down here. Okay, So what I've done is I've cut out everything that might be something that's both green and swims, because nothing is green and swims. And then finally, our conclusion, no ducks swim, therefore no ducks swim. And so when we're looking at the validity using Venn diagrams of categorical statements, what we're going to do is we're going to fill in bubbles here, and then we're going to see if this statement holds, if this statement is possible given what we've drawn in our Venn diagram. So no ducks swim. We're looking at these two circles now, and it looks like the only thing that could exist, so in this part of the circle, would be swimming things, but the intersection of ducks and swimming things has been shaded out, meaning that nothing is there. So our conclusion on the basis of these two premises is that it's impossible for there to be a duck that swims, and that's going to be valid, right? Because we've shaded out the whole area where there would be swimming ducks. Now, this can be confusing given the example, because ducks swim, right? It's true that ducks swim, but our argument is valid. So what valid means then, and sort of just to reiterate what we learned in the first week, what valid means is that if all of our premises are true, then our conclusion must also be true, right? So if these premises are both true, then it must logically be the case that our conclusion is true. And what we see is that given the way in which we formalized this categorical syllogism in the Venn diagram, is that it is valid, that if those premises were true, then the conclusion must be true. Then it must be the case that nothing can exist here where things are both ducks and swimming. So here's this interesting distinction between truth and validity that we should be on the lookout for in all of our arguments. So the strength of an argument depends upon its validity first, upon its logical form. Is the argument that's being given or the statements that are being held together with some sort of logical form, do they have logical consistency, or are they valid together? And only once we decide whether they're valid together can we move on to determine the truth of the argument, whether or not it's a good argument. So an argument can be good in virtue of its validity, and it can also be good in virtue of its truth. But with regard to logic, what we're interested in is validity. And in our next section, when we're doing truth tables, we're going to look at what makes certain logical forms true and false. And then we're going to combine this section that has to do with validity with our truth tables that determine truth. And it's going to turn out that when an argument is valid, that the premises necessitate the truth of the conclusion, and the premises are also true, then our argument is sound. And this is the highest standard for an argument. So what we have is validity and soundness. And the strength of an argument, again, depends first upon validity, and then we do a little bit of investigation into truth. And if it turns out that the argument is sound as well, this is the best kind of argument that we can give. So this is an interesting and tricky example because we're showing validity, even though it's a false conclusion. It's still valid given the premises. So let's move on to the next one. Some Jell-O is grape flavor, and all Jell-O is jiggly. So we're going to mark out our terms here: Jell-O and grape flavor. Again, Jell-O, right, and jiggly. And then our conclusion, therefore, some jiggly stuff is grape flavored. So I'm going to circle jiggly and grape flavored. Okay, and let's use this one, our bottom left, and we'll say that P equals Jell-O, Q equals jiggly, and R equals grape. And I could just as well have used the variables J, I, and G that would have been okay as well. Again, what matters is the consistency in variables, not which variables you choose. Anything can stand for x, just so long as it always stands for x, right? Okay, so here we have our first statement is a sum statement, and our second statement is an all statement. I highly recommend looking for all statements and no statements. We want to find our universals first. It makes the diagramming much easier, and in fact, you're going to run into some logical problems when you try to do existential sum statements first, because you won't know where to put your x, right? So if I say that, for instance, some Jello is jiggly, I could put an x here, right, at Jello and jiggly, but I could also put an x here. And importantly, these are different logical categories. This part of the circle right here is just the intersection of things that are Jello and jiggly, but are not grape flavored. So say like strawberry flavored or fruit punch flavored Jello, right? But here is where we have jiggly Jello that's also grape flavored. But all that I've said is that some Jello is jiggly, so I can't decide where to put my x just on the basis of that sentence alone. It doesn't give me enough information. So what we should do is, when diagramming our categorical syllogisms, again, is always look for the universals, which are going to be our all and none or no statements. So all Jello is jiggly. Here's our two circles, Jello and jiggly. Okay, I apologize for the cut. I made a mistake in my first iteration. I confused myself. So let's do it right this time. Okay, so we have Jello, jiggly, and grape flavored. What we're going to do first is carve out our universal statement, because we're going to want to look at universal statements first, which says that all Jello is jiggly. So if something is Jello, then it must be jiggly, which means that there's nothing which is Jello that isn't jiggly. So we're gonna shade in the area of objects that are Jello but not jiggly, because those don't exist. Okay, and then some Jello is grape flavored. So now we're looking at these two circles, right? Given these two circles, some Jello is grape flavored, but it can't be here, right? Because we've marked out this area. So what I'm going to do is I'm going to draw my x in the middle, because this is the area where things can still be. They can't be here because it's been shaded, but it's also Jello and grape flavored. Okay, so on the basis of these two premises, we have our conclusion: some jiggly stuff is grape flavored. And what do? Well, some jiggly stuff is grape flavored. Do we need to put in another x? No, we just need to look at the Venn diagram that we've drawn here. Is it valid? Is this a valid inference on the basis of these two conclusions? Well, all it's saying is that something exists which is jiggly and grape flavored, and right here we have an x, which says that something exists right here. And in this middle intersection, we have the properties grape, Jello, and jiggly. So something exists which is jiggly and grape flavored, and it turns out that it's Jello as well. So this is going to be a valid inference as well, because we can see that the conclusion picks out the sum object that exists in the middle of our Venn diagrams. Okay. And on to our third argument. So just real quick, I'm going to write valid here. And this one was valid too. Okay, so we have witches, hermits, and young. Okay, sorry for the second cut. My camera died, so I'm having some technical difficulties today. Let's restart with our third argument here, which is x prime for witches, x prime 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 for young, and x prime prime for hermit. Again, that's right here. It says that some witches are not hermits, no hermits are young, therefore some witches are not young. Okay, so again, we're going to start with our universal statement, which is saying that no hermits are young. So we're looking at these two bubbles, the young and the hermit, and it's not the case that anything exists at their intersection. There are no young hermits. Okay. And then now that we have our universal down, we're going to move on to our particular, which is that some witches are not hermits. But here we run into a problem. Some witches are not hermits, which means that we're not going to put an X in here because that would be a witch that's a hermit. But a witch that's not a hermit could either be in this circle or it could be in this circle. But just saying that some witches are not hermits isn't enough information to tell us which. It could be an old witch or it could be a young witch, but neither of which are hermits. But because the logical language doesn't give us enough information to tell, what I'm going to have to do is draw an X on the line, which is to indicate that it's either the case that something is here or here, but we don't know where, right? So our conclusion then is that some witches are not young. So our conclusion would say that something exists here. But here's the problem, and the reason that this argument form is invalid, is that our conclusion indicates that something lives here, but what if, and it's logically possible that, the some witches that are not hermits are young witches, that they live in this intersection here. Well, then our conclusion wouldn't track the truth of the world. And so the premises of our argument, if true, do not guarantee the truth of the conclusion. And because of this, because we can't tell which of these parts of the circle we need to put our X in, but the conclusion tells us that there's an X here, our argument form is invalid. The truth of the premises does not necessitate the truth of that conclusion. Okay, and let's do our last one. All squares are rectangles, so let's make A squares and C rectangles, and some parallelograms are not square, so let's make B parallelogram. Okay, and just to show, I'm going to circle our terms here. So all squares are rectangles, right? If something is a square, then it's a rectangle, so there's no such thing as a square that's not a rectangle. So I'm going to shade in here. Some parallelograms are not squares. Okay, so some parallelograms are not squares. We're going to be looking at these two circles, right? The parallelogram and the square, which means that our X is going to go here. Because it could be the case that the some parallelogram that isn't a square, oh, sorry, it's not going to go there. It's going to go here. Because it could be the case that the parallelogram that's not a square is just a parallelogram or is also a rectangle. But again, we don't have the ability to determine which of those is the case. So what I have to do is put my X on the line. And then our conclusion, some parallelograms, I'll circle these terms as well, some parallelograms are not rectangles, is just to say, well, it's the case that there's some parallelogram that isn't a rectangle which exists there. But again, like our problem with the witch and young and hermit example, all that I know is that something exists either here or here, but I don't know for certain that it exists there, and yet the conclusion tells me that something does exist there. That conclusion is an invalid inference on the basis of these premises, because the premises just give us the disjunctive or, right? They don't give us a certain something exists. So that one's going to be invalid as well. Okay, so just to conclude, these are some examples of categorical syllogisms, and I've given you some strategies and tools for understanding how to characterize and formalize them with Venn diagrams, and some, again, strategies for doing that in an easier sort of way, right? Again, look at your universal statements first and then do your particular ones. Here's a fun hint for you. All of these arguments that we've done are arguments that appear on your quiz. All that I've done is change the terms. So if you're familiar with these forms of argument, you change the terms around to what's in the quiz, and you have your answers for those of you who are watching the videos. And for those of you who are, I'm still going to be available to meet for extra credit sessions. Just like a 5-minute meeting, come say hi. So please email me for that if you'd like the extra credit points. I'd like to meet you regardless, but it's up to you and your schedule. And let me know if you have any questions about the video. I'm happy to field whatever questions you have about the course, the quiz, or anything coming up. I think next week we move on to truth tables, which is fun stuff.